Taxodium distichum, the bald cypress, also known as the tree with the knees. This unique tree is the black sheep of the Cupressaceae family. Most of the trees in this family are evergreens and keep their leaves all year round, but not the bald cypress. It loses its leaves in the winter months. The bald cypress is a conifer, which means that it produces seed cones that feed many animals, a lot like my grandma. The bald cypress appears to have another thing in common with grandmas. They can get really old. The oldest documented bald cypress is around 1,600 years old. These trees can grow to a height of over 100 feet tall. Growing to that height is quite a feat when we consider the wetland habitat that these trees prefer. You might be wondering how this saturated soil-loving tree can support its height. It might be the wide base, something that's treasured among woodworkers for the quality in its heartwood. But some believe that the secret is in the knees. The purpose of this video is to explore this and other unique adaptations of the bald cypress. So let's hear some more about the tree's knees. For that, we turn to Scott.
Hi there, my name is Scott Graham. Have you ever thought, why is it that this tree can grow in water but a pine tree cannot? This tree is called the bald cypress. Its Latin name is Taxodium distichum. Also known as Louisiana's state tree, it is very common in the swamps here. The bald cypress is specially adapted to grow in water because of a combination of unique physical adaptations. Some of these adaptations include the cypress's prop roots, adventitious roots, and the reason for its signature wide base caused by stem hypertrophy. The two main adaptations the bald cypress has, though, are the knees and the rhynchoma. We'll go into further detail about these adaptations shortly. Hopefully, by the end of this video, you'll know how they work and make the bald cypress so well adapted to its wetland habitat. If you have ever seen a bald cypress tree, you might have also seen these woody protrusions growing under it. What are they? Well, to be honest, scientists aren't entirely sure exactly what they do. These knees, as they are called, are connected to the underground root system of the tree. They can range from a few inches tall all the way up to a few feet tall, but typically grow at just above the normal water level. Even though so much research has been focused on the cypress knees, little definitive information has been found. Many theories exist as speculation about what true purpose these unique knees serve. Some theorize that they may help in anchoring the tree in flooded conditions. Another theory is that they help to break up wave energy and keep this marsh dweller upright. Others believe that their purpose is to act as a storage vessel for carbohydrates. But the most popular and long-standing theory is that they are used to help the tree take in oxygen from the air to be used in the flooded roots where oxygen is not available. This seems like a logical possibility, but studies have shown they do not facilitate an oxygen transportation down to the flooded roots. Their true purpose is likely to be in any combination of these functions. Hopefully, more research will be done on the knees, and maybe one day we will know the primary function of them. For now, though, we can just enjoy them and the uniqueness they bring to the landscape. Brady will tell us about the next physical adaptation that has been proven to help in oxygen transportation.
A rhynchoma is a porous tissue that forms within plants. Here, we see a microscopic cross-section of various tissues of the bald cypress. The spacious voids, labeled AR, are the rhynchoma we're discussing. Note that the porous channels are arranged in bundles that facilitate the diffusion of gases like ethylene and oxygen, both of which are necessary for the plant's survival, differentiation, and growth. These bundles, with their straw-like channels, are one of the adaptations that makes Taxodium so well adapted to life in a wetland environment. As you can imagine, the knees on the bald cypress are filled with rhynchoma, and studies have illustrated that the presence of this tissue and its ability to facilitate gaseous diffusion are pivotal for the bald cypress's ability to survive in a wetland environment. Here we can see a figure from one such study. This figure illustrates that in flooded conditions, the bald cypress is able to increase its tissue's porosity. Note the differences between the measure of the tissue's porosity before flooding, as illustrated by the bars that have diagonal hashings. In comparison, the bars without hashings are the porosity after the plants were subjected to 90 days of flooding. we can see that while porosity increased across the board, the adventitious roots had the greatest amount of increase in a flooded environment. These adventitious roots can give rise to the signature knees of the bald cypress. In understanding one of the functions of the tissues that make up the cypress's signature knees, we are able to identify at least one of the functions of these mysterious protrusions. So today we've learned about the bald cypress's famed knees and the parenchyma that make up some of this tissue. We've seen some of their design and proposed function. Hopefully, future research can point us towards what their supreme function might be. For now, let's appreciate what we do know about this beautiful tree.